Welcome to The Explainer. Today we're digging into the one component that's really the living, beating heart of a microbial fuel cell.
Okay, let's just jump right in with a pretty wild idea. What if tiny, living bacteria could actually generate electricity for us?
The thing is, it's not science fiction at all. It's the whole idea behind microbial fuel cells. You'll hear them called MFCs. And they do something amazing. They take waste and turn it into power.
Right, so you're probably thinking, if this is so great, why aren't they everywhere? Good question. And the answer, a lot of the time, points to one single piece of the puzzle that can be, well, a real pain. It's a frustratingly weak link. All right, let's get into it. The power from mud problem. If you've ever tried building one of these and you're just not getting the juice you expected, I'm willing to bet the problem isn't your bacteria or what you're feeding them. 9 times out of 10, the weak link is the anode. So what does this anode actually do, and why is it so important? I mean, how can one little part be the key to the whole thing? Okay, think of the anode as a home, or maybe like a busy hub for these special power-producing bacteria called exoelectrons. These little guys are the real heroes here. They munch on waste, and in the process, they release electrons. And the anode? Its entire job is to catch all those electrons. And here's the crucial part. It's all about community. You can't just have a few bacteria hanging out. You need a full-on, thriving city of them, a biofilm that covers the entire anode. That strong community is what turns a weak little cell into an absolute powerhouse. And look at this. This really shows you what's at stake. A good, healthy biofilm can boost your power output by 2, even 5 times. That is not a small change. That's a total game changer. Okay, so we need to build this bustling bacterial city. The question is, what does the perfect home for them look like? What's the anatomy of a superanode that's going to give us maximum performance? Well, it really comes down to 4 key things. You need a huge surface area, lots of room for the bacteria to live. You need it to be super conductive so electrons can travel easily. It has to be biocompatible, non-toxic, so you don't kill your tiny workforce. And of course, it needs to be tough, resistant to corrosion so it lasts. Let's stick with that surface area idea for a sec. It's just like real estate, right? The more space you have, the bigger the city of bacteria you can build. And we're talking about a lot of space. The best ones have anywhere from 100 to 1,000 square meters per gram. That's insane.
So we've got the blueprint. Now let's meet the contenders. What are the actual materials people are using to build the foundation for this biofilm?
Here's a quick showdown of the top 4. You've got graphene-coated felt, graphite brushes, carbon cloth, and biochar. Each one has its own strengths, its own best use case, from super high-tech lab stuff to big real-world applications. And this is where it gets really interesting, because you immediately see this trade-off. It's performance versus sustainability. On one hand, you have the champion, graphene-coated felt, for just raw power. On the other, the eco-warrior, biochar, which is all about being green.
And to really hammer home what a difference the material makes, check this out. We're not talking about a small improvement here. Going from standard carbon to a graphene coating, it's a massive leap in power.
I mean, look at that number, a 300% power gain. That's just staggering. And that is why graphene is the absolute gold standard for research when all you care about is squeezing out every last drop of power. Okay, but here's the thing. Picking the right material, that's only half the battle. How you actually prepare it is just as important if you want to get a great result. So there are a few simple steps for success. You want to modify the surface, maybe rough it up a bit so bacteria can grab on better. You add good collectors like titanium wire to channel the electrons. You got to monitor the biofilm and be really gentle when you clean it. It's all about making sure you get the most out of whatever material you choose.
All right, we've gone through a lot here. Materials, biofilms, surface area. So what's the big takeaway? What's the one thing you absolutely need to remember about your MFC's powerful heart?
Here it is. The anode is the engine of your MFC. It's not just some passive part. It's what makes the whole thing go. So your choice of material and how you prepare it, that directly scales how much power you're going to get, period.
Which, leaves us with a really cool final thought. Now that we know how to build a stronger heart for this living battery, what are we going to power with it first?